Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G and this time we're going to be solving another question. This one is for the grade 10 and it's on electric circuit. Electric circuit is a very important topic, it's quite problematic and it's also going to help to the grade 11 and grade 12 maybe. Okay, so this question was question 5 done in the KZN province in South Africa. And we're going to solve the question. But before we solve the question, don't forget to subscribe for the channel so you can get the notifications and videos I post on regular basis. The question say a battery consisting of 3 identical cells of a known EMF is connected to 4 resistors as shown in the circuit diagram below. And here is the circuit diagram. Here we have the battery and we don't know the EMF of the battery. The voltmeter reads 12 volt while the ammeter 2 reads 2 amperes. So the voltmeter is only for that specific resistor and the current is only for that specific resistor there as well. Now, before we move on, the 6 ohm resistor and the 12 ohm resistors are connected in parallel. In parallel, the potential difference is the same. I think you must write that note somewhere. You can write that note somewhere. In parallel, potential difference is the same and therefore the potential difference of the 12 ohm resistor is going to be equal to 12 volts. That is important to know for now. Second important thing is that current divides when it reaches a parallel connection. So for this connection that is in parallel, the current is going to split. It's going to divide in different parts. We follow the current comes all this way, as you can see. When it reaches this specific point, it's going to go a little bit up and a little bit down. That is how current is going to flow in this specific circuit. Okay, now what else we know? We know that current is inversely proportional to resistance. What does it mean? It means that for the same voltage, so let me write here V. For the same voltage, the one that have a greater resistance will get a less current. The one that have less resistance will get more current. Guys, you can now stop the video and write those notes. Those are important notes. The resistor with more resistance will get less current. The resistor with less resistance will get more current. That is very important before we even answer the question. The voltmeter reads 12 volt while ammeter 8 reads 1 volt. We already say that. Define the EMF of the battery. That one is a definition. Just for control, remember the EMF is not other thing than the voltage of the battery. That is what we're dealing with. And you learn that voltage is equal to work done per unit charge. That is the definition of voltage or potential difference that you learn here in grade 10. And this one is also applicable for grade 11. If you are in grade 11 watching the video, this is very much applicable for you. Now, only for grade 10 and 11, this is the total voltage or potential difference of the circuit. This is wrong. It's only for grade 10 and 11. This is just for you to get an idea. This only for grade 10 and 11 only. If you are in grade 12, remember there is an external voltage, there is an internal voltage, there is a drop in potential difference, etc. that you will learn eventually when you are in grade 12. Okay? But now, what is the definition of the EMF? Well, this here will help you with the definition. This here will help you with the definition, but we apply it for the battery. So it's that formula, but just for the battery. So it's work done per unit charge. That is the formula by the battery. These are the two marks. That is the definition of EMF you need to give in this specific question. Question 5.2.1. Calculate the effective resistance of the parallel connection. So only for that parallel connection to calculate the equivalent resistance. Alright, so this is the parallel connection that we are dealing with. We have to calculate the equivalent resistance of the parallel connection. In other words, they're asking you to calculate the parallel resistance. The formula, one of the formula is 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. We have two resistors, that's why I only place 2. So 1 divided by Rp, which is what you are looking for, is equal to 1 divided by 6 plus 1 divided by 12. Alright? When you solve this one, you'll get that 1 over Rp is equal to 1 over 4. Now, note, the Rp is the denominator, so we have to get the inverse. Rp is equal to 1/4 to the -1. If you don't want to do this, you just shoot the numbers. So Rp is equal to 4 ohm. That is the answer. Okay, that is option 1. You can do that one with option 1. That question is 3 marks, which means 1, 2, and 3 marks. Now, guys, alternatively, you can say that Rp is equal to R1, R2 divided by R1 plus R2. This one is only for 2 resistors. You cannot use this one if you have more than 2 resistors. Alright, but here is applicable. So Rp is equal to 6 times 12 divided by 6 plus 12, and that one will give you 4 ohm. End of the story. So you can use either of the two options, you will get the same answer. Okay, the next question says calculate the reading of the ammeter A1. Now, where is 8.1? 8.1 is here on top. 8.1 is reading the total current of the circuit. There are different ways of doing this one. First, we can use the parallel connection because we know the current of this specific resistor there. Alright, so we're going to use that one. Remember, we are looking for the total current of the circuit. So this is our circuit, and this is what we're looking. We're looking for that current. Now, note the following. What we have here. We have that R1 is equal to half R2. You can see this one, R1 is 6 and R2 is 12. Therefore, it means that current that flow through the second resistor, I'm going to call it I2, or let me not write I2, I of the 12 ohm is equal to half the current that goes through the 6 ohm. Okay, so let me repeat. Because the resistance of R1 is half the resistance of R2, as you can see there, it will get double the amount of current. Okay, it will get double the amount of current. And we know that this current is 2 amperes. That one is given to you, 2 amperes. It means that from here will be 1 ampere because it's double the resistance will be half the current. So the current through the 12 ohm resistor will be equal to half current 1, which is 2 amperes. Alright, let me take off the ampere. We don't need to substitute the number. So current for the 12 ohm resistor is equal to 1 ampere. What is the total current of the circuit at this specific point? Total current, right here, total current will be the addition of 2 plus 1 because it's the combination of those two. Alright, this is 3 amperes. This is using just looking at the circuit and knowing that it's half. Now, alternatively, you can use Ohm's law. That one is applicable for grade 11 and 12. However, I'm sure in grade 10 you already mentioned and use Ohm's law because it's extremely easy. So if you use Ohm's law, what we're looking for the total current, you can calculate the total current of the parallel circuit, which is the same. Okay, so we can say that the current in parallel circuit is equal to potential difference in the parallel circuit, which we already have it, is known, it is 12 volts, divided by the resistance in a parallel circuit, which we did just calculate. Right? So if we do this one here, we have that the potential difference in the parallel circuit is 12, and the resistance in parallel we just calculated and is 4. So it's 4 ohm. So the answer here is 3 ampere. Quite simple. You can see it's even easier than understanding that a specific parallel connection things. So that is the answer. Marking wise, you can use 1, 2, 3. There's 3 mark for this one, or 1, 2, and 3. So it's quite simple. It's entirely up to you. And I hope you understand. There may be more methods to do it. You can use the Ohm's law to calculate the resistance for R2 first, and then you add. But it's quite simple. Now, question 5.2.3, calculate the energy transfer for the resistor 3 ohm of the resistance R3 in 2 minutes. Where is R3? Is the on the corner there. Here is R3. Now, what we are looking for? We are looking for energy. And let me show you. Energy can be used letter W, or can be used E as well. This is energy. And in what formula do we have energy? Look here, guys. In the potential difference formula, there we have energy. All right. So potential difference is equal to energy, which is W, divided by charge. That is the formula that can help us to calculate energy. However, we have a problem. We do not have a charge. We do not have the charge, and we also don't have the potential difference for that specific resistor there. So the first thing we're going to do is to calculate the potential difference, guys, and without much struggle. We're going to use Ohm's law. You already see here one example of Ohm's law, so we do have to struggle. However, you can look at the number of resistance. You have another one that is equal to that one, and it's quite simple to get. But let's use Ohm's law to calculate the potential difference. So saying that we have that current for the R3, you must always identify where you work, and it's equal to the potential difference for R3, which is what we are looking for, divided by R3. Note the following. Current is the same in the circuit. Is the same in the circuit. So the current is going to be equal to 3 amperes. We just calculated there. So those are important notes. I hope you are writing the notes in there. Saying that, you can come here and substitute. Let me use a new page. My page is almost done. So this one is 3 is equal to potential difference, which is what we are actually looking for, because remember, we need to calculate energy. Potential difference, which is going to be calculated, divided by R3, which is 2 ohms. Is 2 ohms there. So when you calculate this one, potential difference through R3 is equal to 6 volts. There we go. We have the potential difference, but we still need the charge. Remember that we're looking for energy, and potential difference is equal to energy divided by charge. We're looking for energy. This here is question mark. We have now the potential difference, but we still have to look for charge. Where are we going to look for charge? Well, we have to go now to the definition of current. Current is equal to the rate of flow of charge. This is current and is the rate of flow of charge. This is the definition. Oh my goodness. Charge. This is the definition of current, guys. It's a formula. It's given to you in the formulas at the end of the exam, and it's the definition of current. So using this one, we can calculate now the charge. We do have the time. They gave us the time. All right. So they gave that formula to you. I didn't go to the formulas. Actually, we have to look in what way they give it. Okay, here we are. So that is the formula for potential difference at this specific point, and the formula for current. See how they gave to you. Charge is equal to current times time. I'm not sure in all question papers exams is the same. I think I saw it in the way I did write it in another question paper. But well, it doesn't really matter here. The current, we already have it. The current is going to be 3. We calculated that this is the total current charge, we are looking for it, and the time is given to us, which is 2 minutes, but you cannot work in minutes. So this one will be 2 times 60 because 1 minute has 60 seconds. Well, when you calculate, you will get that charge is equal to 360 columns. Quite simple. Well, we are now having the data. We can calculate the energy that we're dealing or we're looking for. So we write in the formula now, which is potential difference is equal to energy or work done divided by charge, and we substitute. So the potential difference we calculated is 6 volts. You substitute in here 6 volts is equal to work, which is what we're looking for, and the charge is equal to 360. So the energy or the work done is equal to 2160 joules. That is the answer. Now, marking wise, this question have a lot of work, so they gave 1 mark for multiplying this, for substituting in here. Okay, they gave 1 mark there. They gave 1 mark for the substitution to calculate charge. They gave 1 mark for the formula of potential difference, and they give 1 mark for the substitution and 1 mark for the final answer. This is a total of 5 marks. 1, 2, 3, 4, and 5 marks. That is how they mark this question. I hope you get it right. Now, the next question say EMF of each cell. Now, to calculate the EMF of each cell, we'll need the total EMF, so the total voltage, okay? So to calculate the total voltage, all we'll have to do is to add the different potential difference in here, which we already know the potential difference through the 2 ohm resistor, and this part we calculated because we need it. And this one was potential difference here was 6 volts. All right, that potential difference was 6 volts. Note, the potential difference through R4 must be the same because it have the same resistance. So potential difference here is equal to 6. And through the parallel is 12. So what is the total potential difference of the circuit? So V total, which I'm going to, let me change this color, the total potential difference, which is equal to the EMF of the battery, all right, it's going to be EMF of the battery. Let me write it like EMF, like this, is equal to the addition of all that. So it's 6 plus 12 plus 6. 6 plus 12 plus 6. Okay, there we go. This is equal to 24 volt. That is the total potential difference of the battery, but they don't want that. They want for each cell. Guys, this is quite simple. You have 1, 2, and 3 cells. Just in case somebody don't understand, here we have 1 cell, there's 2 cells, there are 3 cells. So each of them now, this potential difference will be divided evenly among all those cells. So what you have to say, the potential difference of each cell, the EMF of each cell is going to be equal to 24 divided by 3 because we have 3 cells. So the answer is 8 volt. Each cell or each part of that specific battery, we have a potential difference of 8 volts. Marking, they gave 1 mark for calculating the total, and then they gave 1 mark by dividing by 3, and 1 final mark in here. It's quite simple. A fifth resistor R5 is now connected in parallel to R4. So you come here, R4 is here on the left, and now what they did is they connect a parallel cell to a resistor to that one there. So let me erase it here, and that is what they did. They connect a new resistor of R5 there. Okay, now, will the EMF of the battery increase, decreases, or remain the same? Note, the EMF of the battery is constant. You cannot change the EMF of a battery. You cannot change. Batteries, when you buy a battery at the shop, already come with certain voltage. You cannot increase it. If you want to increase it, you have to get a new battery. So EMF is constant. In other words, it will remain the same all the time. It does not change. It doesn't matter what happened to the circuit. On this part here, the EMF will always stay the same. In this case is 24 volts. Will the reading of A1 increases, decrease, or remain the same? Now, the A1 is the total current of the circuit. And look here, guys. Look what we did right here towards the beginning of this specific question. So we have to look what happened to the total resistance of the circuit. Now, let's write some notes. We can answer here, enough space. This is one note for you to write down. And not just to write it down, but memorize it, because this is an important statement for grade 10, grade 11, grade 12. The explanation is a little bit different, but this is important. The more resistors in parallel, the more resistance you add to the circuit in parallel, the smaller the total resistance, the greater the current. So what is going to happen? It's going to increase. Why is going to increase? Because we adding more resistors in parallel, therefore the total resistance decreases. So you have to say increases, our total is going to decrease. If you add resistors in parallel, please write that. I cannot get stressed enough. You must write that one so you understand. The total resistance decreases, therefore the current increases. Total current. Note the following. In grade 12, when you explain such things is not necessarily the same, you have to use another formula. But guys, thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel, write comments. You can ask questions. Thank you. I'll see you next time. Mr. G here.